locked us out of the mainframe.
Who's locked you out of the mainframe?
The mainframe is out of the coolant!
You can access the mainframe by remote.
I hacked into the mainframe at the bank.
It's like they dumped their entire mainframe onto our fax and into our computer.
So what are these mainframes that we keep hearing about good for? Welcome to the Moshik's Mainframe channel. This is Moshik's. And today, this video is going to be about people who don't really want to have any intention to start programming or install stuff. They just want to know what these mainframes are. And this is what this video is about. Mainframes are at the very basic just giant computers like this one. What you see here, where this man is walking, all this is just one computer. All this racks you see out there, this is just one part of one computer. This is not many computers. What you see in the lower left corner, where it says 3090-200, that is the CPU, just the CPU. And all these other devices you see here in the background, these are all disk devices. But it is one computer. And that is a mainframe. So mainframes are in the very essence centralized computers run by businesses or governments. They have been around for a long time, over 50 years now. In fact, the very first computers created back in the 40s and 50s were mainframes, where there would be one computer accessed by many people. In fact, the notion that every computer, every user, every person should have a computer or more than one computer was totally foreign and totally strange idea until the 70s, and people couldn't think of why a person would need a computer. And when the first PCs, personal computers, came out, people were like, why do we need computers and when the mainframe is so much more powerful? And so they were designed from the get-go to process very large numbers of business records. So what I'm talking about is when you have a credit card company that needs to process millions or billions of transactions every day, or sometimes even every hour or every second. The normal computers, even servers that we know from our offices or from our workplace, they don't cut it. You need computers that are able to process much larger quantities of data. And so they're not designed for a client computing experience. They're not designed to look cool and to move things with a mouse or copy objects with just a Control-C, Control-V. They're designed for one thing only, which is to move and process large amounts of data. Not to be confused, however, with supercomputers. Supercomputers are a completely different thing. Supercomputers are there to process large amounts of numbers. So those are for number crunching, whereas mainframes are not for number crunching. They're for business or records crunching. So a government that has hundreds of millions of citizens, they will have to process hundreds of millions of records. An insurance company that has millions of customers every month will have to process millions and millions of invoices. Those are the kind of use cases where mainframes shine. So today they're being used, and they have, in fact, for the last 50, 60 years, 70 years, they've been used to store the most important business data and government data. They cost many millions a piece. When you just saw, when I showed you just the CPU in the data center we just saw a few seconds ago, just the CPU alone will cost millions of dollars a piece. And because they're so expensive and because they have very sensitive data, which our records, your data, my data, they're usually being kept out of the public eye. And that's why mainframes have become kind of mystical beings. People hear about them, but you never see them because very few people actually get to see a mainframe. In fact, I've known people who for 40 years have been programming mainframe computers, and they've never even seen or touched the computer itself because they were in a different building or sometimes in a different state, a different country, and there's no need to touch or see the computer because the separation between the users and the programmers and the physical hardware is complete when it comes to the mainframe. What you see here is how a modern mainframe made by IBM looks like. Again, this is just the processor, what's called the central processing unit, and then there would be many devices here that you cannot see behind this one, where the data is stored, where many petabytes, many thousands or millions of gigabytes or terabytes of storage is being kept online, accessible for programs to process them, like credit card transactions or toll booth records or your tax records. Those would all be stored on a mainframe. And so this is how a mainframe looked in the 60s. Okay, not much different, just the looks a little different, and it's black and white, and the guy here seems pretty happy to be working on a mainframe. But so these two photographs are here to show you that there's been an undiscontinued, so a continuous line of computers that have been processing business and government records for the last 60-70 years. And the most amazing thing about this mainframe is that whatever programs used to run 50 years ago still run today. Now, of course, one of the first questions, it's human, it's normal to ask about any new environment or computer system is, what does the user interface look like? And so this, what you see on your screen here, would have been the very typical user interface for people working at, in this case, I guess it would be at a university, or maybe at a company where in the HR department, and that's how people would interface with a green screen terminal or with a dumb terminal. That's how they would have opened a particular program on the terminal, and they would have filled up all this data and then press enter, and then they would have been sent to the mainframe. It was very normal, and still is, of course, for a mainframe to have sometimes 2,000, 5,000, 10,000, even 30,000 terminals attached to it. And it's through those terminals that people would interface with the terminal. And we're going to, in a few minutes, we're going to see a session with a terminal, so you can imagine what the terminal session looked like. By the way, this was already quite an innovation to have a terminal. In the early days of mainframes, you had punch cards. We all heard about those. But this was from the late 60s, early 70s on until maybe the early 2000s. And I would guess in some cases still today, for instance, airlines, you still see airlines using green terminals when you go to the check-in counter. What they're really running is an application like this one. And so for many years, this was how people were interfacing with the terminal. And as I said, this is where the terminal really, the mainframe really shines, when you have millions and millions and millions of records like this one that have to be kept and analyzed and processed. Now, fast forward to 2018, and this is how an interface with the mainframe would look today. Very similar to any other web application you have. You can use the browser and interface with the. You would never suspect that behind this simple web page there's actually a terminal, a mainframe application running. So this is how this would look today. Of course, any variation of this. Whenever you log into your Citibank credit card web page and want to see your past transaction, you're actually interfacing with the mainframe there. Whenever you go to your airline booking web page and book a trip, you're interfacing with the terminal there. So this is today the mainframe is undistinguishable from the user perspective point of view. You just don't know anymore. Now let's look at what it was like, or still is like today, to access a mainframe with a terminal application. So when we hear the word terminal, what do we mean by that? From the 60s until maybe the early 90s, this is how people work with a terminal. It was a rather bigger screen often with a detached keyboard. This is an IBM terminal, and this is a color terminal, which was already an innovation that came maybe about mid 80s or end of 80s. I myself worked, when I started working mainframes, I had just green as a color, and there was no differentiation whatsoever. You had to read very carefully through every field to keep things apart. And then the more senior people used to have color terminals such as this one, which made things a lot easier to read. I was a programmer, so especially when you look at computer code on a terminal, having color coded was a huge improvement in productivity. But only senior people back in the mid 80s were allowed to have this. I had just a plain green one. And so from the early 70s through the early 90s, for about 20 years, people used to have mainframe terminals like this. They were dumb terminals. They could not run any program. All they could do is connect to the mainframe and run programs on the mainframe. The other thing is the mainframe, you would only send data when you pressed enter. That's when you send your data to the mainframe. The mainframe was totally disconnected from whatever was on the screen until you pressed enter again. And so there was no animation, obviously, there was no graphic. This was all 80 bytes across times 24 lines, sometimes 40 lines high. And when you would put in your data, and whenever you finish inputting your data, you would press enter here on the keyboard, and then you would update your data to the mainframe. The mainframe would process it and return the results back on the screen, which is different from what we use from Windows and other operating systems on a PC today, where every time you press a key, even just an alphabet key or a shift key, the computer knows you're pressing it. On the terminal, the mainframe doesn't know you're pressing the key until you're done putting data, whatever in the fields you need to put in, and then press enter. And we have a demo of this in just in a few minutes. And so from the 90s on, this all became virtual. So all this was replaced by program, usually running on Windows, which would emulate what the terminal did. And you can see here, this window here, that's a terminal emulator. So this is a program running on usually Windows, which would emulate all of this here, all this device on the left, with just a simple program. And so you would connect to a mainframe. In this case, this is the address of the mainframe. And there you would log in and work just as if you had a real terminal here. Of course, one of the many advantages of having a virtual terminal or a terminal emulator is that you could have many of these open at the same time, whereas you could only have one terminal on the desk, sometimes two, but that's about it. I still read today about the U.S. military having some applications which require two terminals being on a soldier's desk. She has to read data from one and then input it into the other because the systems are not connected. Obviously, all this becomes much easier in today's world. But so this is a very typical screen that you would get on a terminal. This is all, as you can see, is character based. There's no graphic whatsoever. All graphics are made with characters. And so this is how people have been accessing mainframes from the early 90s, mid 90s until today. And this is more for the programmers. And as we've seen in the previous page, in users that use the mainframe to process data would today probably use web pages to interface with the mainframe. But programmers still use terminal emulators. How does a terminal emulation look like? So this is a terminal emulation here. I'll make this giant screen. So right now I'm connected to a mainframe, and this is a very typical screen that you see. And I'm using, by the way, the same terminal emulator we just saw on the picture next to the real old age terminal, the virtual terminal I just talked about. This is the same program. So right now I'm connected to a real mainframe. So you can see here I press enter and things get updated. As you can see, this is all just characters. There's no even the graphic here is done with characters. And I do have color, obviously, because in Windows everything is color. And let's see what it means like to work with a mainframe. First of all, this would be a programmer's access of a mainframe, not an end user's program access of the mainframe. So let's see what I can do here. I could take here would be how you program mainframes. As you can see, everything is uppercase. There's no lowercase, and there's a very special language you use to interface with the terminal, with the mainframe. Sorry. In this case, this mainframe is an IBM mainframe running the MVS operating system, and which stands for multiple virtual storage. It's from the mid-80s, but it still runs today just fine. And in this case, I'm running a program to uncompress what you would call in the Windows world a zip package, a zip file. Here's just a simple program in a programming language called PL1, where I display some stuff, I process some information and then print it out. Now, one thing to say about the mainframe, it is to a big extent a batch-oriented operating system, which means that mainframes are very good at running a program where there is no interface at all with the user. Everything is done in batch, meaning that you give it data in, it processes it, and then it outputs data, and there's no need to talk to a user because all the actions that need to be specified are built into the program. There's a second way to work with the mainframe, which is what we're doing actually right here, which is interactive or dialogue oriented, and it's also what we saw in this way of working. So this would be an end user working online interactively to input data or through a web page. But the other way to do it is to work in batch, and so programs run typically in batch. And what we're going to do right now is we're going to take a program, run it in batch, and look at the output. There is no file system on the mainframe, especially not on the MVS, that we can compare directly to the Windows file system. Things are done a little bit differently on the mainframe. You need to specify where files are going to be on the disk, and there's very primitive searching capability for files. So I can search here, for instance, by specifying just a little bit of information, but it's not like you have in Windows. So this is a real mainframe application. I'm interfacing with a real mainframe right now. The fact that the mainframe that this is running on is emulated on something called Hercules is not really of primary importance to our discussion today. And I'm picking here up a COBOL program. Here it is. And so I have a program, and I'm going to run it in batch, meaning that there's no user interaction whatsoever once I start it. I'm accessing, of course, this program in an editor, in a code editor as a programmer. And what this program does is it finds prime numbers. So this is COBOL. For all of you who ever heard about COBOL all the time, COBOL, I write it up here on the top of the screen. This is what this is, COBOL. And there's still billions, many billions of lines of COBOL source code running all over. Credit card companies, insurance companies, airline companies, the government is using it, any government is using COBOL. Any kind of application where you have millions of records, there's somewhere COBOL running. Now people think COBOL cannot do math. This is math here, absolutely can. Of course it's very verbose. You would say in COBOL multiply I by I, resulting in square root. So add 1 to I. So in COBOL you don't just say things like I equals I plus 1 as you would do, let's say, in the C programming language. In COBOL you have to say add 1 to I, which I think is actually elegant. To me it's elegant and beautiful. This is one of the very first programming languages. The first one was Fortran. COBOL was maybe the second programming language, and this was written for an IBM 360 mainframe, which we just saw in the pictures before. And so now that we looked at it a little bit, we're going to do prime numbers up to 9,000. Now remember, mainframe is not meant to be a supercomputer. Those are different things. Supercomputers are number crunchers. Mainframes are record crunches, business record crunches, or government record crunches. So let's start this program. This will go very, very fast. It will not take more than maybe hundredths of a second. Submit. So you can see here a job. This is a batch job, has been executed, job number 971. And now we go look at the output. Typically the output actually goes straight to a printer, but in this case I intercepted the output and I'm going to look it on the screen. And this is the output of running this job, this program. And what I see here is just the operating system telling me, MBS in this case, telling me what it did with this program. It tells me that it returned code 0 means that there was no errors whatsoever found. And through, it tells me all the things they had to do to start this program. And we also find out how long it took to run this program. If you look here, so this was started and ended within a second, but I'm sure this is through second boundary, so it couldn't have been much longer than, we'll find out exactly how long it took. But so this took, so that's a third of a second in total. A third of a second to find the first 9,000 prime numbers. And here is the compilation step. The compiler is from 1972, still runs today just fine, as I promised at the beginning of this video. So you can see here, IBM American National Standard COBOL. This program was built in 1972, still runs fine today. And this is the output from the COBOL compilation. And these are the prime numbers. Now, presentation is not the strength, is not the forte of the mainframe. In today's world, you would have very nice output in a window as a Windows application. The mainframe is not built for this. Mainframe is built to process large numbers of records. But here it is. If any of you want to see a different example, we can use Fortran. We have Fortran here as well. This uppercase, everything has to be uppercase in the mainframe, and I'll tell it that I want to look at the output on the screen, not on the printer. So here you have Fortran. Still, of course, everything is uppercase. Many of you will recognize the Fortran. This is obviously ancient Fortran from the 60s, so this will be a 50-year-old program. And let's see how long it takes to execute this program. So program 972. Let's switch, and here it is already, obviously. So this also had no errors whatsoever. And of course, this is now a different compiler. We have the OS 360, which is a previous name for MVS, the operating system I'm connected to right now, Fortran, from 1974. So this would be a 44-year-old compiler, versus the COBOL compiler we just saw before was a 46-year-old compiler. So this is compiled and gave me the results here. So this is what it means like to work with a mainframe. It's a completely different user interface paradigm, completely different from what we know from Windows or even from other alternative operating systems such as Linux. It really just runs fine. It's a different architecture altogether. There's no file system, but it's very productive. And mainframes are really, from the programmer point of view, mainframes are built to be programmed. Of course, there is packaged software to be found for mainframes today, such as Oracle, DB2 databases, SAP runs, of course, on the mainframe, and many, many others. But it is a programming. It's almost an ideal programming environment, such as Linux. I myself use Linux quite a bit, and I would say that Linux is the ideal programming environment, and the mainframe is the other one. They're completely different, not compatible with each other. And by the way, you could also run Linux on the mainframe, of course. This is what it is. And so here's an example of using color to provide information and try to be as graphic as possible. This is a performance monitoring software that monitors the performance of the mainframe. and it's telling us right now that the CPU is at 0%, 1%, not very busy at all. And so this uses color on a character terminal emulator or terminal to convey information. This is how people are used to work on the terminal. In this particular case, let's look at the size of this mainframe. This mainframe, I know, has 16 megabytes of memory, 16 megabytes, that's not gigabytes, with one processor. And it can have 120, up to 120 users can connect to it, which it could easily handle. Back in my days when I was programming on a mainframe, we had also 16 megabytes of memory, also one processor, just exactly like this one. And if I'm not mistaken, let's see, this is the type of computer. It doesn't show here, but I think this is very similar to the computer I was running in the 80s, and on 16 megabytes of memory, 16, one processor, we had about 100 programmers working concurrently at the same time, and about 3,000 users online doing the kind of data processing that I showed before with masks such as this ones on real terminals. Back in those days, we had real hardware terminals such as the one here on the left. About 3,000 people doing this kind of work, and then another 100 people doing the programming work that I'm just showing you here on this terminal. So this is what the terminal, what the mainframe is all about, this gives you just a little bit of a taste of what it means like to work with mainframes, how mainframes process information, what they're supposed to do, and I hope this demystifies a little bit some of the stuff we hear when we hear about mainframes in the movies. Mainframes is just a place where big amounts of data are stored and where they're being processed for business or government purposes. I had fun making this video. I hope this helped you in understanding mainframes better. If you like this video, please press on the thumbs up button. And if you want to learn more about mainframes, please consider subscribing to my channel. Thank you very much, and goodbye.
I access the mainframe.
Check the computer.
The mainframe computer.
God damn it, you're in the mainframe.
He's locked us out of the mainframe.
Who's locked you out of the mainframe?
The mainframe is out of the coolant!
You can access the mainframe by remote.
I hacked into the mainframe at the bank.
The mainframe.
I can't find a Canadian server. I've got to break into the mainframe.
I sent an engineer to check the mainframe.
Looks like they dumped their entire mainframe onto our fax and into our computer.
Cross-check that bastard's profile with the mainframe at Langley.
Yes, Mom.
Someone's tampered with the POTUS mainframe.
So all we have to do is load it anywhere into the credit union mainframe.
The mainframe computer.